Radon is a radioactive element that occurs naturally in our environment. Radon is element number 86, and it has the chemical symbol Rn, which you can see in the lower right-hand side of the periodic table. Because radon is in group 8 of the periodic table, it is a noble gas, like helium, neon, and the other elements that are in group 8. It has a very short half-life, only 3.8 days, which means that it doesn't stick around very long after it forms. When it decays, it emits radiation and transforms into a lighter element. So where does radon come from? Radon is formed as part of the decay chain for uranium, thorium, radium, and other heavy radioactive elements. The environment around us has trace amounts of uranium and other radioactive elements in the soil, which are continually decaying into lighter elements and giving off radiation in the form of alpha particles and beta particles. This process is continually producing radon, which you can see indicated in red in the middle of the decay chain for uranium and thorium. Much of the radon that is generated underground remains there and decays shortly after it forms. However, some of the radon that forms in the soil emerges into the atmosphere, and this accounts for the low levels of radon gas that are found everywhere on Earth. The average concentration of radon in the air outdoors is about 0.4 picocuries per liter. We are exposed to this low level of radioactivity all of our lives, no matter where we live, but it is not completely harmless. Radon is believed to be the leading cause of lung cancer deaths in non-smokers. Because of geology, southeastern Pennsylvania has increased levels of uranium and thorium in the soil. Problems can arise when radon emerges from the soil and accumulates inside of buildings. This happens when radioactive elements such as uranium and thorium in the soil under the foundation of the home or the building decay and generate radon gas that enters the basement through cracks in the foundation. Years ago, nobody expected that radon gas could accumulate to dangerous levels inside a building. But that all changed in 1984 because of an event that occurred very close to our campus. In 1984, the Limerick Nuclear Generating Station near here was under construction. Stan Watrous, one of the construction engineers, needed to enter an area of the plant that was protected by a radiation detector. When he passed through the detector, he set off a radiation alarm, indicating that he had somehow become contaminated with radioactive material. This triggered a safety investigation because it was unclear how he could possibly have come into contact with enough radioactive material to trigger the alarm. Investigators eventually went to his house in Boyertown, which is located just north of Pottstown, and they discovered extraordinarily high levels of radioactivity inside his home, with levels as high as 2,700 picocuries per liter. This is more than 6,000 times higher than the level of radon that naturally occurs outdoors. He was told that breathing the air inside his house was equivalent to smoking 135 packs of cigarettes a day. Over the months after that, engineers realized that his house had been built on soil that was high in uranium and other radioactive elements. They designed and built a ventilation system that created a vacuum under the foundation of his home and pulled the radon outside. And they also sealed up cracks in the foundation that were letting radon enter the basement. This system brought levels of radon down to a safe threshold of 4 picocuries per liter. He and his family still live in the same house, and they're doing okay. Stan Watrous later started his own company installing radon remediation systems in homes throughout our region. It is estimated that 40% of homes in Pennsylvania have elevated levels of radon. About 12 years ago, I discovered that levels of radon in my basement were about 30 times higher than outdoors. I contacted Stan Watrous, and he installed the system that continues to operate in my basement at home and has enabled the levels of radon to remain essentially below the 4 picocurie per liter safety threshold. The CR39 polymer that you're analyzing in this experiment was exposed to indoor air at a home near our campus several years ago. The radon in the air caused spots to form in the polymer. You'll count these spots to estimate the amount of radon that was present in the home, following the procedures that are outlined in the lab manual.